Okay, welcome back. Now we're going to look at example 4.12, which is talking about how we calculate what's called a z-score, which is going to standardize our standard deviations. And basically what a z-score is going to tell us is how many standard deviations away from the mean is any particular score. So just to get a little understanding, let's take a look at this. We happen to have what's called a normal bell-shaped curve here and a couple things. Here is what percentage of our data falls within one standard deviation away from the mean. So 34.13 falls from 0 to 1 standard deviation, another 34% from 0 to -1 standard deviation. So typically they'll say 68% of our data falls within one standard deviation. If I go out to 2 standard deviations, it's another 13 or 14 plus the 68. I get close to 95% of my data is going to fall within there. And within 3 standard deviations, about 99.7%. So this gives you how many standard deviations away from the mean. This gives you your cumulative percentage. And this gives you your different percentiles. And this gives you your z-score. Now what's important here is all this z-score is, notice, is it's the same as the standard deviation. So if I have a z-score of 0, I'm right at the mean. A z-score of -1 means I'm -1 standard deviation away from the mean. -2 means I'm -2 standard deviations away from the mean. Same on the positive side. So what this allows us, a z-score allows us to do, is look at how many standard deviations am I away from the mean. Now the way you calculate that is for a sample, which is what we have here. It's any individual score, any x, minus the average, the mean, divided by the standard deviation. And if I have a population, it's the same thing, except the mean is mu and the standard deviation is this. So you've got the same thing, except this is where the population is known. This is where we just have a sample. So I took this purchase order data, and if I wanted to know the z-score for any one, notice there's a thing. I don't have to do the calculations, or I could. It's called standardize. And so I say standardize, and then I said standardize my purchase order. Notice I said standardize. Well, let me do it for you in this query. You go up to F2, you say let's go to statistics and look up standardize. Standardize. All right. What is the x? Well, let's do it for all of them. My x is this right there. What is my mean? Well, we calculated the mean earlier. So let's go find that mean that we calculated. There's our mean. And our standard deviation. And then we want the standard deviation for a sample, which is right there. We hit OK. And you see we get negative 0.2 standard deviations. Now that sort of should make intuitive sense to us. 17,000 order. We know the mean or the average is 26,000. So we know we're below the mean. We're somewhere over here. So negative 0.02 would be somewhere in this range here on our curve. Notice 127,000. We got a standard deviation or a z-score of 3.3 standard deviations away from the mean. So it's way to the right of the mean, which makes sense. 127,000 is much bigger than our mean of 26,000. And what did we say our standard deviation was? Our standard deviation was about 30,000. So that would make sense. 3 standard deviations, 90 plus a mean, yeah, this is going to be about 3 standard deviations. Notice this one. 42,000 is going to be to the right of our mean, 103,000, 2.5. So that's where a z-score comes in. It becomes very, very powerful because once we standardize it and get a standardized score, we can now use tables or Excel or other statistical tools, software tools, to tell us what is the probability of that event happening. Hope this helps.